I was thinking that people with.
All right, so that's the part of the school that you've been patiently waiting for. So now you will be actually able to do some exercises on your computers and practice the software for the electronic collider. Kauder from BNL agreed to give a set of tutorials for the second time. Thank you. We did it one time.
Yeah.
Ready? Now it's going to be 3 hours of tutorials. And I think.
Oh,
How many hours? 2?
wait, today 3 hours? Okay, good. Okay,
I was
okay.
cancel that.
I mean, I can make that material stretch, but.
I'm not keeping an eye on the numbers. So we trust that by the end of the tutorials, you're going to be able to do the analysis of the data. So please make sure that you follow is going to be taught such that you qualify them to some homeworks.
All right. I do want to start with a presentation, a short one, but before we get to that, let me ask you, show of hands, who has EIC shell installed? 1. Okay, sweet. We did not get the message out. All right. Who has no access to lab resources? Who cannot SSH into, be it BNL or JLab? That's about 10 of you. Any one of those in the last show of hands with anything other than a Mac? Good. All right. So those of you who are at the lab, please log into. Oops. Please log into your lab of choice. The reason why we're starting with this is because it will take 10 to 15 minutes depending on download speed. Of course, it doesn't matter. We do it the hard way. So make yourself somewhere in the scratch area or in your work area, a working directory where you would like to be. And then from the material that is posted, that is attached to the Indico, there is, let's pull that up too. This bottom part, setting up the environment, go there and click on setup. There's a whole bunch of stuff, but what you really want to do is just do this. If you can, do it on a lab computer. If you cannot, do it in your regular shell on your Mac. You see on the lab, it works fast. And what you should be seeing on the Mac is something like this for quite some time. All right, so while that's going through,
Can you show them the comment that we have to execute?
oh,
What is curl? Okay.
you can type it out by hand too, obviously.
Yeah, no, I'm just opening.
We got this snazzy little email address, not email address, domain.
I missed the second step.
This is the only important step.
Yeah.
So essentially, you download an installation script and run it automatically through Bash, and it installs itself. Oh, do you have Docker installed? Good. If you don't have Docker installed, do that first. Almost forgot. That is not all that bad, considering how many people are in this room together. Anyway, we'll get back to that in a minute.
Locally or at NL?
This is locally. I've done it locally to demonstrate how slow it is. Yeah.
The lab is busy for us.
Yes. It's also, it works differently. On a Mac, it's in a Docker container, so it downloads the entire image, and you from time to time have to update that image and clean up because it's static in time. While at the lab, it essentially is live.
Just says environment setup successful.
Outstanding. All right, so I'm going to reuse existing material, first because I'm lazy, and second because it's much better, because it allows us to refine this material, to have recordings available. If I'm not very clear, there's recordings of similar tutorials given before by other people. Maybe they do a better job, and you can revisit this at your leisure in various flavors. This is just to show you, we recently had a software meeting at CERN in order to connect with our European colleagues some more. We took an entire day off for tutorials. And if you see this time projection here, that is very optimistic. These things tend to run over. But we'll see how much we can stay in time. And my plan for today is mostly to make sure that you all of you have the IC shell working by tomorrow. But let me give you Holly's talk. And as usual, I failed to go. All right. So just a general overview about how to go about detector studies or physics studies or reconstruction studies, what all involved, what we're talking about. First of all, we took great effort into making this a unified and diverse and careful project. We had long discussions and meetings when we merged the proto collaborations about what software stack to adopt, about the principles that we want to use for these. We have, of course, our diversity of requirements. We are very high on reproducibility, on openness, meaning all of you can use not just the software, all of you can use all of the data we produce. Well, data. All of you, this is completely visible, completely transparent, other than proprietary material for magnets or something like that, of which I have no idea to begin with. And it's collaborative, all of you can contribute. And the last point is the agility, which means the IC shell gets frequent updates and you should stay abreast of those if you keep using it. General structure under the spokesperson, we have software commuting, and it tells you that this is one of 3 equal parts, how important the software aspect is as you ramp up a new project. We have, as I told you, this is from April, so it's slightly older. I am no longer co-convener of user learning. That is now Stephen K, whose tutorial I will present second tomorrow. I am the coordinator for physics and detector simulation. We have dedicated production teams. We have people concentrating on reconstruction and analysis tools. Overarching all of this has to be validated. And finally, we're embarking on a new way of doing business where the entirety of our data will be streamed. There's no such thing as events in EPIC at the data acquisition level. So what's the real experiment look like? You have some kind of EA collision. It goes into your detector. This could also be detector 2 if we get one. This software stack is also collaboration agnostic. It goes into the data acquisition cards and lands on tape, finally gets reconstructed. In large production runs usually, and then analysis follows, and all that is again surrounded by validation to make sure that we're not introducing mistakes. The current setup, if you do this on a computer only, it works like this. You start with the Monte Carlo event generator, which we have probably about 20. Then you run the detector simulation. This is done with GEONT4. That's the standard of how particles interact with detector material. The tool that we use to steer GEONT4 is called DD4HEP. It's part of the Key4HEP suite, and Key4HEP aims to have off-the-shelf, widely available tools for all HEP experiments, and we adopted most of their software stack as well. Then it runs through what we call EIC Recon to get it from hits and clusters to tracks and towers. And then we have the same thing, production run, analysis and validation. In principle, starting from here, this should be identical, and it's planned to be identical. From here, there should be no more distinction between simulated data and real data. So for Monte Carlo, of course, event generators, Pythia is one that's popular, but there's many more boutique variants. There's Sartre for EA collisions. There's Beagle, the standard for electron ion collisions. You can also just use a particle gun. There's other physics that you need to consider. There might be background. In fact, there is a boatload of background from synchrotron radiation and from gas events. And you can count, depending on which energy we're running, that you get for one real signal event, there will be 6 electron gas events in there. There might be tens of thousands of synchrotron radiation photons in there. So you want to merge all of that as well. And just a little thing that's not here, it's just a little piece of interest. The EIC is not built completely straight at the detector. There is an angle, a crossing angle. And to get this crossing angle into it, because most Monte Carlo generators don't have a crossing angle, we have an afterburner step in between. Then, as I said, you drive your GEONT4 with using DD4HEP. You agree on a event data model. That's a long discussion to be had. There was also in every change that what is a track called, what is a track in this particular detector called, and so on. And then you need to digitize, transform these GEONT hits into something that looks like what might come out of a DAC. Do the reconstruction, assuming that you have real data. This is also an important step that's not quite noted here. You, at this stage, have to chunk up your many seconds or milliseconds of continuous stream into what you would consider a real physics event. And, simulation, production, analysis, validation. We'll be focusing here mostly on this last part, because I think that's the most easy to get into. But there are also tutorials for all the other steps if you're more into the detector simulation, detector building steps. We agree, we use HEP-MC3 to describe Monte Carlo particles. That's at this point the de facto standard everywhere. We have the Jana 2 framework from which was used and developed at JLab for their experimental halls to essentially steer all of this recon and simulation stuff that comes out of the simulation. And this speaks to the data models that we have all have agreed. These are written up in large JSON files and then auto-generated. Also, again, coming from the Key4HEP community. Of course, that's all driven by my working group here. Then the construction working group is its own entity. The production working group has the hands full because they keep running production trains every month, all the time. And finally, the analysis working group where physics comes out and physics performance gets evaluated. I won't go too much into this. Essentially, we run analysis campaigns or simulation campaigns every month. By the first day of the first week, you have to have your fixes in or your simulation sets in. Then you test a little bit that it's really working and do more development. These are done as trains. They are automatically done at large scale. And then in the last 2 weeks, we have what we call charters and taxis, which allow a working group to have something specially made for them, or even something small for an individual only. This is a bit old, because obviously we're now up to 24.05 point something, or 6 might already be done as well. Not much to discuss here. This is all quite technical, but you will see these kinds of paths quite often. So we might as well work through it here. This is essentially where everything starts. That's just boilerplate. And then there will be reconstructed particles. There will be full events. That's after the JAN simulation. And there will be event gen sub trees where you can get like the Monte Carlo truth out of it. This describes, EPIC is the name, Crater Lake describes the current iteration of the design. We went through, essentially they're named after national parks. We went through Arches and Bryce Canyon, and we're now at Crater Lake. Crater Lake has been around for a long time, so I think we're getting really close to final. The kind of process, sub-process in this case, neutral current, energy combination, and Q-squares. And then underneath these, there will be files for you to read. So the question then becomes, for this group, assuming you all want to now get involved and do many contributions, what is there to study? You can concentrate on resolutions and efficiencies. There's the whole digitization aspect, getting more optimal. Geometry can be optimized. Geometry must be fixed and updated and get made clearer and clearer. You might be more interested in the physics, phase space acceptance, and the algorithms used to get something from the physics objects. So for the detector study, you would use the existing geometry or maybe modify the geometry or modify the digitization. So this uses all of these steps remain the same. You focus on this part. If you want to implement a new detector, be it from scratch or more likely at this stage, making something better, then you need to also figure out how to get the digitization right and how to use the reconstruction of your new detector. Also note that under all of these, there are clickable links to previous tutorials on doing all of that. For physics studies, you use an existing generator. You can use the entire campaign, or you can implement a new generator, or you can request a simulation from the production team. This is naming schemes. I will skip this. Or you might want to make the reconstruction better, or run a new analysis, build on a new analysis. then you might want to also need to work on EIC. There's an analysis bootcamp, both, like we're going to be talking about something, but there's also a Python version on the website. And finally, validation is an important tool for us. All our code lives on GitHub. All of our code runs constantly continuous integration and continuous development tests. And for these, we need benchmarks, and those benchmarks can be developed. You can find them here. That's essentially a small but important analysis you might want to make and see how your performance currently runs at it. What do we need? We need users. And then we need, these people need to make requests on GitHub. There will be a discussion on the request. There will be a whole litany of tests automatically run through it. And they will sometimes find some annoying code style suggestions that need to be cleared up. But most of the time, this is really the step where we make the most progress between one person having an initial idea and then the whole team getting together to work on that. We have a Mattermost help desk and many channels in there, actually. We have these tutorials. We have a site with frequently asked questions, and all that adds up to a sustainable software effort that is so critical for us. So there's a picture of it, but it's easier if you go straight to the source. So eic.github.io is where most of our documentation and things like that lives. And there's a starting point with 4 big things to help you get started. These are some things you can do once you get more involved with EIC. There is, of course, the question of becoming a member of the GitHub. As a read-only member, that's easy enough. If you want to contribute, you should talk to your sponsor, to working group administrator. It's not hard to get the right access if you're a prolific contributor. We have a Mattermost channel that you're invited to join. And of course, we have mailing lists. There's more than these, but this is like the main mailing list. And this is our computation and software mailing list. There's a long wiki we have. I'm just going to flash that one. You can see how much stuff is going on here. More information about the detector subcommittees, the working groups, the working group conveners, where you might want to get involved. Okay. After you got started, maybe you have some general questions about how to run HEP-like software. Maybe you're not very familiar with the Unix shell. Maybe Git is not exactly your first language. And the HSF software, the HEP Software Foundation has put together many tutorials on the basics and the advanced things. Also advanced Git and so on. To give you an example. Nope. I was looking for. Yes. If you look at this design, you will soon see more of it. Essentially, we have this framework of putting together tutorials, which lists things at the top that are important, prerequisites. That's the setup that we just clicked on and got to the curl link. And then some guesstimates on the times it will take to do some things with introductions, with usually code examples where you can copy paste straight up out of the tutorials. This is an amazing resource for pretty much all your needs that we can't cover because they're too general. We have frequently asked questions, and you're more than welcome to add to those. There's an email link specifically to the help desk. Hopefully you will find what you need in here already if you have a question. If you think something is basic and needed and not really clarified, please let us know. And we have the tutorials. And instead of just clicking on the Indico link that's been sent around, you can just straight up go from here, which is what I will be doing. As you can see, this one has been recorded a couple times already. We have a YouTube channel where these appear. I think Holly's recording isn't actually up yet, but should be linked soon as well. And I will be focusing on these two. And there's more linked to in the presentation as well on how to do anything else, how to modify a detector, how to modify an algorithm, how to modify a plugin, all of these things. Let's get right in it. So how are things looking? Has everybody's install finished? So once you have that, what you want to do is run EIC shell. If you don't have your Docker client running, it might complain at this point, and it will probably take a little bit of time on the Docker as well. What's that?
If you're running on a cluster, is that okay to run on login mode?
Yes, this is a not at the head, but like an interactive node should not be a problem.
So
Java 500 Wi-Fi.
I'm running on SVUs.
Okay.
Yeah, one of the interactive SVX nodes.
Will not allow you to do
Hmm?
it. JLab will probably will not allow you to do it at logging node. To go for logging, then to one of the nodes that I.
Yeah, exactly.
That's
Yeah.
where you would be able to run.
Yeah, on SVC you couldn't because the login node is so restricted that you can't even show the directory contents. And there you have it. This is all of the software of the EIC Epic. The first thing you may want to do is check out where the detectors live. So you see prior versions tagged by the campaign. Epic main is always the current one. And if you just source the setup there, never mind. I know what's happening. They recently changed the language there, of course. Okay, what this does is it puts a few environmental marks in your environment, specifically fingers are not as they used to be. It shows you where the current version of Epic lives, what it's called, and what the configuration is. Not very tricky here, but you see you can choose different definitions. So Epic is a full huge detector with, I think, 20 subsystems, beamlines, magnets, and what have you. You may not always be interested in that. And you can find custom versions that use only vertexing, only the calorimeters and what have you. This is important mostly if you want to run the simulation by yourself, which we're not going to get into today. Just wanted to show you what all lives here. There is a tool called npsim in your paths now, which we won't run because that is essentially the DD4 wrapper around JR4. There's a tool called EIC Recon, which is used to do the reconstruction. There is a beacon, the afterburner, and so on and so forth. All part of this tool. So this is a curated selection of our software. It also has root installation in there, which usually is at the bleeding edge of the root version that's released, or the latest stable version at least. And this is one of the main reasons why we use this container. Like if you log into just SDCC, you have a C++ version that is more than 10 years old. You have root versions sometimes that still start at 5. This is not something we can do. It's also something that is not homogeneous across the two host stacks. And it's not something that we can enforce that can be expected on your laptops. So what we have instead is something that should work, does work hopefully for everybody. Oh, yes, making my point here again. ACTS is another important package that we use for track reconstruction. All of these tools, pretty much all of them that are listed here and more that are named, are from existing experiments or from something like Bell 2 or Dune or what have you. We really want to not reinvent the wheel. Also, it allows us easier bug fixing, easier bug hunting, because if you find a bug in your own little ecosystem, we don't know where that comes from. That might be any number of things to do with paths, with old versions, with different versions of root and what have you. If there's a reproducible bug in EIC shell, we know exactly what to look for and where to look. We can file a bug report and somebody will be on it and has an idea of what to do. That said, you're not required to use it. There are some parts of it that I sometimes will just install standalone because they're so small and easier to do than trying to run it through EIC shell. If you haven't done so, here are the instructions again how to get it. There's many ways of getting it. The most important is you could click on this link that will lead you to a text file. You save it as a text file on your computer and you source it from there. Here, yeah, as you can see, or as you saw, it's fairly slow. I'm impressed by the Wi-Fi here. I sometimes, on like an airport or something, if I have to do this, it will take forever. I will show you one thing too, while we're added here for the Docker users. Where is my Docker pen? So this is a fresh install that you just saw me make. I, however, have my own working environment somewhere else, and it is currently out of date, presumed. So what I'm going to do is upgrade it, which it needs to do frequently. Oh, that was good. I got lucky. Here's something to keep in mind, and I don't think it's in the description. Docker loves to keep all these old files around. So right now there's at least one dead image worth 13 gigabytes on my disk. What you do is of course. I tried that one. Yeah. So now prune the existing images. Oh, no example to show. Usually, before I do this too regularly, but at some point I discovered that I had 10 dead images lying around. That is just not a good practice. They also display in your Docker panel if you look at that sometimes. Here's also, you know what, we're also going to demonstrate collaborative work with Git. Because there's a tiny typo or an error in here, let's change that. Because 10 gigabytes is no longer true. So you can, these tutorial pages, you can edit directly on the repository. And automatically create a pull request. So this is in fact something that would be great if you go through these tutorials and some of them are outdated, some of them just might be wrong, some of them might be missing something. I would really appreciate if you would make these short edits and pull requests. You're not directly editing anything. You can't destroy anything. It just creates a pull request that lets us know that we should look into this, that you propose a fix, and we will most likely pull it and send you thank you. Okay, so what if you now exit this container? And then you enter it again. What it does is it completely forgets its previous existence. So you need to source this setup file again to get the environment back. If you install something in the container using something like apt install, which does work, then it will forget about that too and reset itself. However, all of your local file systems are completely mounted and working. So if I touch a file here, I create a new file. I exit, and it's still there. I go back in. I wait for Docker to do its thing. It will still be there. That's my point. You can install local versions of all of those software packages if you want to work on your own EIC recon installation, if you want to use your own version of DD4HEP, and they will remain in this directory. This is just the starting directory where you start. Your entire mount system should be visible. That includes the GPFS directories on SDCC's farms. That should include all of the Scratch directories and the user directories at iFarm, at JLab. So the system software you can't install and hope it to remain, but everything else will work just fine. So assume I want to now create a file in here that's not just empty. I want to work with something, a text file. I think VI may be installed. There is probably a text-only Emacs version still installed, but this is not really the environment where you want to open a text browser, but no problem at all, because we can access it from a different place. You can use your favorite browser here, which for me currently is VS Code. And it works just normal, because it's local. If you're on the farm, then you would just log into another node as well. You have two windows open, and you do it from there. I always just work with two windows, one that is essentially local, whatever that means, whether it's on the farm or local, and one that's inside EIC shell. It does have support for some graphics. So if you, for example, do start a T browser, it works. That's a note in the tutorial that I haven't deleted yet. That this doesn't work on Mac. That's not true anymore, or at least it shouldn't be true. And if you are on a Mac right now, I encourage you to try this because that's the one where I've encountered the most arcane problems. Because somehow something always breaks. And if you can all open a T browser or a T canvas from within the shell, then I'm happy and my work is almost done. How are things doing so far? Everything here? Any questions?
I'm getting an error about too many symbolic links. Trying to find. I don't.
Oh,
So this has Aptinger loaded, not Singularity, because we don't have Singularity.
Okay, we have candidate one to stay after. And we'll try to fix this up. Everybody else has it working?
you know, like at the point that we launched root, right?
I think
Yeah.
I'm essentially through my program almost. I'm shocked. I did not expect that to work so well.
It might mean two things. Either everybody failed or everybody succeeded.
So I have no access.
So you have the same problem or you don't have the same problem?
Totally different problem. I don't have access to JLab and also don't have a Mac.
Yep, I'll get together with you then, Shu. So there is something to do here with PRs. What I would do instead, you want to, I suggest that we go back to the tutorials page and you look at the setup instructions of the next lesson and maybe work a little bit into the introduction as you want for yourself, just free work. Any questions that come up in the meantime, ask me and I will take care of getting the last two EIC shells to run, hopefully. That sounds good? Speak up. All right. Oh.
Yeah.
What happens if you just paste the thing into?
Oh, because it doesn't have like curl.
No, it should have curl. I just know nothing about this new shell. Ah. Got it. What's the this shell?
CMDs.
Yeah. Marvel.
Of course. Luckily, we really get through all of this.
You get
The problem is like the certificates too, right? So there's something like unsafe or so.
Open store.
You.
The other thing you want me to try, PowerShell.
Yeah.
Yes, yes.
Yeah.
Yes.
And so.
I was wondering whether that's the same thing now.
You could also try Song of the Cell.
Yeah, that would be the other thing to do would be Windows subsystem
Yeah.
aligning.
Yes, yes, that's the word that I've heard used about where it's
Yeah,
So.
that takes a little while, but it's still be the best.
Notice, you don't know how this
Front PowerShell.
with us works, but we don't have the singularity, we just have voices.
No,
I'm not sure if that matters.
So this is
That'd be
on.
engaged.
That's good.
This is on a cluster from my university.
Okay. And you don't have CFNs.
I have CBMFS, but we don't have the singularity one.
Yeah.
So I'm not sure
Basically give you a bash.
how that works.
Shell.
I don't know how to. Yeah, I said that.
Yeah. So. Did you download install? Yes, right?
Because I ran the command.
Okay. Pull up my computer, share.
You were
The problem is that your CDMFS is probably not set up to see that particular path, and you don't have. Probably don't have the power to change that. No, it's right. Still right. Suggesting to me as well. Actually, there's some.
I was looking this way, not to.
Yes, it does.
Well, it's just. Might do everything.
Oh. Okay.
You want me to download the file?
No, I mean, I have it for some reason. Ah. So there should be, we've lobbied for an option to use the Docker version. Docker.
No, they blocked that.
What kind of role would they allow you to change?
Probably not much. There's not a way to direct.
You know, shell, solo shell unit, so singularity, so singularity, you need to have go and solo.
I will look.
First thing is down.
I don't know. They have just that's what I see.
Tuesday.
So what's on?
It's right.
Oh, yeah.
It's a full. It's off the parallels.
Right.
So just put your things on parallels or.
So I'm pretty sure that means basically just right.
Yeah. No, you'll want to use the Windows terminal. But go into, you need to go into app settings and Windows features, and enable WSL or Windows or subsystems for Linux. And then go into the app store and just search a button and then install that.
Oh, reading on that from the terminal.
There might be a way.
Yeah, I'm already.
The stores.
So you should, yeah. Let's get this back.
Change it. I was gonna look at it.
So this is
Algo así. Luego le di. Después de eso, pero no sé qué vamos a salir. Ahí le di Max. Todavía lo está descargando. Y ya empezó, ya no me deja agarrar.
Yeah, I'm seeing if I can, because I definitely not installed CVMs, but I might be able to.
You don't need to install it. I think the problem is just that it doesn't have.
You don't think that would?
Because it needs to be in this particular stuff.
Yeah. Yeah, I'm definitely not able to modify that.
However, you might be able to ask.
Yes. I get Fred to do that because
Period.
more likely.
And then you. Christmas. Okay. 200 of them. Who do I forward it to? No.
Good.
I'm not sure.
That's-
That's. I mean, you can go back. Next time.
Yeah, I'll try that.
Then you- so that's- And then you install Go, yeah.
Yeah, I did not in.
I know people who do. That, performance variance, that's usually also the ones.
Once you've got WSL installed, it's basically its own Ubuntu environment, so it should run exactly like. Yeah, it's completely, it's basically, yeah.
Then the only question is if there needs to be any changes to this.
Oh, no, I did.
Now,
Yeah.
running. I can't expect, if I run, I'm not gonna get a,
Yeah.
Yes, you will. New T browser or new T canvas.
It's a pretty-
Space.
Oh, you mean a GUI for root in general?
Yeah.
Ah, no. Root is I can show you some things you can, I mean, this will be something we're gonna do tomorrow. But in general, what you do with root is you code macros in C++. And it's interpreted C++ counts. But
Oh, you, have one.
Yes.
Okay. Yes. Probably better. I did, I picked a cube. Nice settings, add those to it. Instead of what it was for every single flavor.
But I get yours and just because I did a few.
Yeah, I used to. I did it in the original style, but I just put it like right here or something, like in the middle of everything.
Yeah.
So I just rewrote everything at the end. Yeah.
These trees. It's a whole bunch. So you can see there's many objects, but
No. Standard IO. That's standard IO, so if you want to print some. Or you take user input or you print things out.
if somebody sends them my.
Probably do, because you probably are going to have to deal with statements.
Yeah,
Because you
yeah.
don't want to change. Okay, yeah, so you need standard IO.
Is that just like?
Yeah, but there's, yeah, but very basic ones in C are factor like standard lib,
And I just.
standard IO, like not right without standard IO. Yeah.
And then,
The number of.
some digging around.
Function 5 gram, protected unit has 4
Sound far again.
You should do that in front. Do you have a default parameter?
Oh, so whatever.
Okay. Can you do it in C?
Right.
Please,
Right.
like a void for a function.
Yeah.
Void, a void function doesn't return. Shows no return value.
Okay, right. Cluster in there.
And they don't care too much about max. But it more
Whatever
neat
you want to
and
return. You have to
many
take
other
what you want to
people
return.
actually use it on a Mac. This has to be.
Something like.
So you have to say the name of the function, what kind of thing it returns.
Possible. I'm just happy that nobody
You can only return
have a part that's show. It's really annoying. That's
Which returns. Yep.
a different matter. We have this nice.
Oh, that just doesn't, no, that might mean it
And,
doesn't make any arguments.
Want to run some HDL stuff on
You
it.
don't need to have any.
It doesn't transport over to the master. It shows fine on the Linux computer. It shows fine on a
Where did
cell,
you see the?
but somehow it doesn't translate. It allows you some Qt window.
I just saw it. I don't.
It doesn't matter.
I do that.
I don't think it's open. Maybe it is.
Something you have to define every single variable. Like I can't just have product use that. You need everything has a function. I mean, I guess it's the end of the day, everything should.
Yeah. Gotta do it.
Don't use full use the player on the market. It's the same exact thing and it is under the hood a lot better. Long story.
Does it allow?
Yes.
Not that it's just back stall.
So what you just did is essentially just have the daemon install the event stocker. Yeah, now you
There's literally a number called double underscore max that comes from float.h. You can print out that software. I guess it's computer specific.
How do you make an array?
If
I just make an array out of 3 elements right now.
doubles.
Yeah.
What do you wanna name it? Double. Double is array and then open bracket 3.
Thank you.
That's a fixed size.
How's it working on an
I'm
iPad?
gonna get bigger.
No, I saw, hold on, I saw that.
Okay.
Would you?
That's.
The slide you sent for it. Basically,
Yeah. So if you just say, if you don't instantiate it,
so that
say
means
double
like
array 3,
the number of
then there is an array of 3 things just sitting there waiting for you to. It probably has garbage in it.
Essentially, we have
So you can just say array sum 0
different physics.
equals whatever, array sum
Say-
it's whatever.
Yeah, the construction works.
Yeah.
Say
Yeah.
10 million ions, 10 million electrons, 10 million photons in a particle.
That's the same.
Done. So you should
The
try to
CIDF
make it
say
longer than
we
you ever
need
need.
these 10 million pixels
Or
if
If you
they
really
provide
need
them
something
that
where you
have
have a set length, but then you
version and all of that,
dynamically
and ask the
use
production
use dynamic allocation.
Okay, so
and
that's.
it's
Now like
every month it's essentially the same thing. But you're saying because
we just want
just have different
to
iterations.
see dynamic allocation.
But one of the same thing.
So then different campaigns, right?
And then just like cut it all.
They both
Yeah, and then
different,
but you
yeah,
can
the
your variable that's
the construction and
then
the
just put it from 0 to length.
So is that a way to know
Just make
how
sure
many
that length
events
never
will run
hits that number.
for
Or if you,
specific
if you're
group of
doing it
data, for example,
in practice, you
Instead
might know that
yeah.
no matter what you do, you're never gonna hit that number.
Yeah.
So you don't need to care.
current
I mean, that's.
data. Do I have it? Right, 'cause for example, I downloaded, but this is just one data out of the set of data that, but I don't know how many
Then array,
chart.
so you need
Um,
a variable of how long.
I know it is documented somewhere.
Especially if you.
Oh.
Let me try and find out.
Even if you were doing it, it thinks it's 5,000 things long, because it does have 5,000 divs of garbage data sitting there waiting for you to do something.
And then if I want to make a 2D array, that's this, right?
Yeah.
Can I check?
It's easier for you, I can go up there. I don't know, it's crazy. Was it a China do some of that? It's the government.
No, add up each.
Yeah, yeah, survive, survive.
I just do that. I just get Docker.
Forget this, one minus.
Maybe to get.
You have to loop over for every row, for every column. Like array 3 sub ij equals array 1 ij equals array 2 ij.
Okay, so I just.
Yeah, you just have to commit like 4 lines of code. It's one like, you get some really, you can do some really crazy math with arrays. An array in C is a number. So it points. You know anything about pointers? Okay. An array in C is a number. It is the address of the memory of the first thing. So you have somewhere in memory, you have an integer. Somewhere else in memory, you have the entire array. And your array 3 or whatever is just a number somewhere. And just when you say array 3 sub whatever, it goes to that address, moves over however many rows, moves over however many, and then gets them, grabs that up. So another way people write it is instead of
And then EIC records the files that you.
Oh.
the way. So like here.
Dash F S.
Here on this is an array of doubles with and dimensionally long, but this is another way to write an array. This is saying this is a pointer to a double. So it's some X mu is something that will.
I would kind of agree.
And so this is a way to say that you don't know what length the thing is. You're saying there's some list somewhere and this is the name of it.
Essentially, this is how, I mean, that's feedback, but this is roughly the idea of.
Yeah. So those,
That essentially.
file.
Yes, if you run that file, main is the thing that's.
CA.
And then I can create other files.
Oh, so I should,
And so this is
Yes, sir.
a name. So another thing you can do in C is the .h file. You can just have the names of the functions.
Yes.
And so
I
just,
should do some.
what's the
I
name?
think
of
that
the function?
makes
What does
sense.
it take in? What
What I
does it
can
give?
send you.
So the .h file, just like first glance, like what does this file even do?
Go ahead.
It doesn't have any of the actual functions. So it's very lightweight, so standard lib.h is just like a bunch of names and functions. And now you can use them because you know what kind of things you need to put in and what kind of things to get out.
This is, no, this is, this, the one this morning and even see. Files for some reason. So this is a larger. Like really, the strategic planning book.
So that means if I want to, know,
Now,
I think so, yeah.
You can definitely just contact the help desk there and say, hey, how do I find out, how many filings?
Don't,
How many
really don't.
For
Don't take
particular
any
setting
on this.
campaign.
Oh.
They should definitely be able to, yeah. I know they have this documentation. I know they're well documented. Some
reason
instances I just never find it.
Anything in that program, then everything.
But yeah, the help desk is usually help.
We just have.
Okay,
this is
and
the function.
I also look at the files.
Change all-
Thank you so much.
So, and.
It's just like.
Here's,
like array addition.
you have to go through.
So like sometimes mine will become like.
This is my C program that I'm writing, and literally underneath it, I have the Python code pasted, and I'm just. Like, I'm just looking, I'm trying to keep all of it. I don't know why. I'm just looking.
Yes, correct.
Yes.
Yes.
The bottom.
I think this should be the song project.
Anything more before we disperse?
Oh, I should have more.
Excellent, that's why I'm here.
Python is built on top of C.
I'll look.
Hot man.
Michael,
So do you think things because don't pseudo lines. Also seeing with our team.
I don't.
Singularity.
I've never,
Yeah.
if I want to do analysis, I do it in Python. I wouldn't see.
So how are you going to run this? Locally on the Mac or on the phone?
So for now.
C is,
SSH.
C is where you go and something is single, and C is where you go
Okay.
if you want to.
The best thing of
Something really important, check out a program that.
Yep.
Is not.
and you can use singularity or.
I made a program when I took my computer off. Like closing you, I close it to a reopen. And if I tried opening any video games, or that program is open for 2 hours, it would automatically close. So I would turn my computer on and have to work for 2 hours. Visually.
I'm unaware that works. I mean, it would probably be possible to make it.
Probably GSL. It's probably a method in GXL. I would be very surprised if there would.
Oh, wait, how does the pod man differ from singularity?
Almost the same. Owners as the doctor.
It looks actually.
I tried to download that. Tried to view it.
Okay. I'll ask a question, how to do
Say
it.
that.
The question has 0 points. There are 2 answers. Both of them have -1 points.
Alright, I'm looking carefully.
Now that we can start wrapping up, let's first thank, yeah. Any questions for him? I guess, anything that you want to ask? Right away. So as soon as everything is installed, we are done with this.
Yeah, I expected this to crash and burn because it usually does. There were problems.